Good morning, student. So yesterday we have learned about the heat added to the system and how the thermodynamic processes takes its path. Means how the initial state of the system it changes from the initial to final. So how much path does it will take? We have seen the path number 1, path number 2, and the path number 3 also. Then after that we have seen the heat added to the system. Okay. Now we will see that part again. So students, this is our piston and cylinder arrangement. This is our piston and cylinder arrangement as you can see here. Now the gas is enclosed into the cylinder. Suppose the initial temperature of this system was 100 degrees Celsius. Initially it was 100 degrees Celsius. Now we will apply the second case. We are going to apply the same case which we have applied to the piston cylinder arrangement. We have considered in the horizontal way. Okay. So the only difference is here is the vertical piston cylinder arrangement. Okay. So this is what we are going to take example to understand the heat added during the thermodynamic process. Okay. Now suppose the initial temperature is 100 degrees Celsius and suppose I have just started to heat it. Okay. Suppose I have started to heat it, then so this is the external source of heat I have just added to the piston cylinder arrangement. Then what will happen? The heat will added to these gases which are enclosed into the cylinder. Okay. Then these molecule, it's a delta U. Its delta U will be equal to amount of heat energy supplied to it. Okay. The internal energy will be equal to the amount of heat supplied to the gases enclosed into the cylinder by this external source of heat. Then what will happen? This Q, this increase in internal energy will tends to molecules which will apply the force over the surface of the piston. Okay, that's why the piston will move in upward direction. So the piston will move upward direction. So this is the second stage. So as far as this part heat added during the thermodynamic process is concerned, this is in the two stages. In the first stage, the piston was here, okay, before adding the external source of it. And when you just added external source of it, then what will happen? This gaseous molecule will apply the force over the surface of the piston and the piston will move upward direction. Okay, so this will be your second stage in which the piston will move in upward direction. Okay, so this is nothing but the heat added during the thermodynamic process. The heat added will be equal to the delta U, and this delta U will tends to apply the force over the piston, and that force will tends to move the piston in upward direction. In the horizontal case, we have just considered the piston is moving whether right or left. Now as far as this vertical system is concerned, the piston will be moving in upward direction. So this is the difference you have to spot and you have to just understand. Okay. Now we will see the next part now. Now we are going to see the uncontrolled expansion of gas. Now the meaning itself suggests it is the uncontrolled expansion of gas. Means controlled means now till now we have seen the piston and cylinder arrangement. Okay. Now in that arrangement we were able to just control its pressure. Means the force when we are just applying force over the piston, so it was controllable. We were capable to control that force. Okay, that's why the pressure was also controllable. Now in this case we are going to consider the uncontrolled expansion of gas. How does it occur? We are going to see now. Suppose
ग्रुपमध्ये जायचं आणि जी लिंक आहे ना त्या लिंक ते वेगळ्या फिक्स करायचं.
Now students, suppose this is the piston cylinder arrangement. Okay, this is also one of the piston cylinder arrangement in which the gas molecules are enclosed. No way, there is the gas molecules are enclosed, but you can see here there is a breakable partition is there. Breakable partition is there. Okay. So these two sections are there, section number 1 and section number 2. Okay, now the piston cylinder arrangement is now differentiated or the sorted in the section number 1 and section number 2. Okay, this is the first stage or this is the normal arrangement of the piston cylinder. And one more important thing you have to keep in mind is this entire piston cylinder arrangement is insulated. Entire piston cylinder arrangement is insulated, means there will be no exchange of temperature. Okay, means your delta T, there is no, it will be 0, or you can say there is no exchange of heat, means there will be no transfer of temperature and the heat also. Okay, then Q also, Q will be further added, so we will not think about Q. So the temperature transfer will not be there. So as there will be no transfer of temperature, the heat will be also will not transfer. Why it is necessary? Because the entire system, the entire piston cylinder arrangement is isolated. Isolated means there is no transfer of heat, no transfer of temperature, and no any transfer of gaseous molecules also. So in this way, the entire piston cylinder arrangement is totally isolated. You can say the insulated. Now this is the first stage. Now we are going to apply the external source of heat. Okay, we are going to apply the external source of heat. Then what will happen? Suppose in the second case we just apply the external source of heat. Then what will happen? This gas molecules which are separated by the section 1 and the section 2, then this heat, the heat you have supplied will get to this gases which are enclosed into the insulated piston cylinder arrangement. Okay, then you can see the gases will be increased its heat supply, so the delta U will be increasing, so it's a delta U will be increased. So you can say these gases will try to push, this force will be applied over this breakable thin partition. Okay, this force will be applied over this breakable thin partition. Okay, so as you will just keep on hitting, to this external source of, with the help of external source of it, the gases will try to impart the forces over this breakable section, and finally when there will be the certain limit of that breakable section, then this breakable section thin partition will be break down and the gaseous molecule will be rise tremendously, means dynamically it is. Okay, so there will be the no controlled way, so it will be dynamically just move, it will just break this partition and it will dynamically or the explosively it will just break this thin partition, and after that the gases will be spreading in the entire piston cylinder arrangement, in the entire cylinder. Okay, so in this case there will not be any breakable section. Okay, then in the first case there were section 1 and 2 were considered. So because of this partition has broken down now all the gases will be spread into this entire cylinder. Okay, and this is nothing but your uncontrolled expansion of gas. This is nothing but your uncontrolled expansion of your gas. If you take the example of you are just cracking the fire, okay, in Dasera Diwali. So that is when you are just cracking that fire, then the gases which are produced inside that cracker will be just exploded and they are just expanding in uncontrolled way. So there is no any control. So as you may have seen the video of Hiroshima Nagasaki attack, okay, so there will be also uncontrolled way of expansion. Okay, so there is no control over that gases, the gas molecules. So that is the also example of uncontrolled expansion of gas. Okay, this is uncontrolled expansion of gas. So if you want this diagram, you can take this.